Next, we have to discuss about the structure of alkyl halides. So before going into the structure of alkyl halides, it is very important for us to know the structure of alkanes and to know the hybridization of carbon in alkane. So we will start with the simplest alkane, that is the methane. So as you may know that the carbon in methane is sp3 hybridized. So in alkyl halides, what we are doing? We are replacing one hydrogen with that of the halogen atom. So in alkyl halides, the structure will remain same as that of the structure of alkane. So we took the example of methane. So the carbon in methane is sp3 hybridized and the structure is tetrahedral. So similarly, the structure of alkyl halides will be, it will have tetrahedral structure, or we will say it will have tetrahedral geometry, and your halogen will be attached to the sp3 hybridized carbon. Next, we have to discuss about the structure of alkyl halides. As you may know that in alkanes, the carbon is sp3 hybridized. And how we are obtaining alkyl halides? We are just replacing the hydrogen with that of the halogen atom. So obviously the carbon in alkyl halides will also have a sp3 hybridization. Next, we have to see the structure of the alkyl halides. For that, we will see how we are getting the sp3 hybridized carbon and what orbital of the halogen will overlap with this sp3 hybridization. Next, we have to discuss about the structure of alkyl halides. So, if we look at alkyl halide, it is generally represented as Rx. And how we are getting alkyl halide? We are getting alkyl halide from alkanes. So, here we have to start with the electronic configuration of carbon. So if we look at the electronic configuration of carbon, it is 1s2, 2s2 and 2p2. So let's take the outer orbitals, because outer orbital will be the one that will be taking part in bonding or in hybridization. So we have s orbital and here we have p orbital. Let's discuss about the structure of alkyl halides. So in general, how do we write alkyl halides? We write them as Rx. So here your halogen will be attached to carbon atom. So how we are getting these alkyl halides? These alkyl halides are obtained from alkanes. And if we look at the carbon in alkane, taking an example of methane, then this carbon is sp3 hybridized. So let's see how we are getting sp3 hybridized carbon. So if we look at the electronic configuration of carbon, then it is 1s2, 2s2 and 2p2. So how do we write it? We have to take the outermost shell. So these are the one that will be taking part in bonding. So there are 2 electrons in p orbital. Now excitation will take place. So this 1 electron from the s orbital will jump to the orbital, that is the p orbital, and this amount of energy will be available at the room temperature. So now this 2s orbital and 3 2p orbital will undergo mixing, and or we can, in short we say, they get hybridized and they will give us 4 hybridized orbital, all of them having 1 electron. So we get 4 sp3 hybrid orbitals. 4 sp3 hybrid orbitals. So how will they arrange in around the carbon? They will arrange themselves in a way in which there is minimum repulsion between these orbital. And what is that geometry in which there will be minimum repulsion? That is the tetrahedral shape. So this carbon will have tetrahedral geometry. So now if we are taking methane, so if we take an example of methane, simply the 1s orbital of hydrogen will overlap with these sp3 hybridized orbital. So these are sp3 hybridized orbital, this one, this one, this one and this one, and this is the 1s orbital of hydrogen. But now what we are saying is, we are replacing one of the hydrogen with that of the alkane. So what we are saying here now is that we are replacing hydrogen with that of the halogen. So if we look at halogens, that is the fluorine, chlorine, bromine and iodine, then they have 7 electrons in their outermost shell. So what is the number of electron that they require to complete their octet? So it requires 1 electron. And we have this 1 electron in the sp3 hybridized orbital of the carbon. So what will happen is these orbital of the halogen atom will overlap with the sp3 hybridized orbital of carbon. Now if we look at halogens, so the outermost electron is present in the p orbital. So here what will happen is the p orbital of the halogens will overlap with the sp3 hybrid orbital of carbon. So here there will be overlapping of the sp3 hybrid orbital of carbon with that of the p orbital of halogen. That halogen could be chlorine, bromine, or iodine. Depending on that, you could have 2p, 3p, 4p, and 5p orbital. So, similarly, this alkyl halide, that is the Rx, will also have the tetrahedral shape. So, it will arrange itself in space like this, and this angle will be 109.5 degrees. So it will have tetrahedral geometry.